All right, so let's resume this section. There's a lot more to talk about. So we just rolled out the definition of cosine of an angle and sine of an angle. We draw the angle in standard position. There's this point here where the terminal side intersects the unit circle, and we're just keeping track of where is this point. What is its x-coordinate? What is its y-coordinate? Let's just notice, because of the unit circle, the x-coordinate can be at most 1 and at least negative 1. Similarly, the y-coordinate is at most 1 and at least negative 1. So let's just file this away now, because sometimes people make mistakes and they get answers that they should notice are wrong. So let's just note values for cosine and sine. Are always between negative 1 and 1. Right. Later on, you'll be doing computations to find these. You might make a silly mistake and you get, oh, sine of this angle is 2. And you would notice, oh, well, that's clearly wrong. Let me go look for my mistake. So here's a way of thinking about this. The cosine of an angle basically measures how much the terminal side of the angle points to the right on a scale from negative 1 to 1. So if cosine of theta is 1, right? I'm just going to draw some examples here. Don't feel like you have to copy this. Just think about what I'm drawing. Here's my unit circle. Draw my x and y axes. Here is my initial side. Let's make that perfectly straight. We're thinking about this terminal side moving around. And what you want to do is you want to think cosine is basically measuring to what degree does this terminal side point to the right on a scale from negative 1 to 1. So if cosine of theta is 1, it means this terminal side points perfectly to the right. Maybe we have a 0-degree angle where the terminal side also is the positive x-axis. That's what cosine of 1 looks like. Cosine of 1 is where this point, where the terminal side meets the unit circle, is as far to the right as possible. If cosine is negative 1, it means our terminal side goes as far to the left as possible. That would be like so. If cosine is, for example, what do I have in this example? If cosine is negative 0.2, that might look something like so. Let's think of this. Right here is the point negative 1 comma 0. So we're thinking about this x-coordinate. That x-coordinate, we're sort of measuring how far does this thing point to the left or right. Well, it points to the left, so cosine here is negative. But this only points slightly to the left. So we might have something like so if cosine is a small negative number. Remember, we're only doing this on a scale from negative 1 to 1. Great. Cosine equals 0 would mean we're not pointing left or right. So if cosine of theta is 0, our angle might look like this, or our angle might look like this. But if I were to look at this terminal side and say, how far to the right is that pointed? Well, it doesn't point to the right, and it doesn't point to the left. Cosine is 0. Cosine is negative 0.2 means we're pointing to the left a little bit. It might look like this, or it might look like this. There are two possibilities. In each case, the terminal side is pointing slightly to the left. If I have something like cosine of theta is 0.8, that means we're pointing to the right rather substantially, but it's not perfectly to the right. So we might have a picture like so. This terminal side, if I say, is that terminal side pointing to the left or right? Remember, it's starting at the origin, so we have a notion of which direction it's pointed. If it looks like this, Well, it's definitely pointing to the right, but it's not pointing perfectly to the right. So it's not cosine equals 1, but cosine is almost 1. Cosine is a pretty big positive number. It might look like that, or it might look like this. There are two ways of drawing this. In either case, can I do that? In either case, we have this terminal side that is pointing to the right, but not perfectly to the right. So that's what cosine measures. Cosine is basically measuring how far to the right does that terminal side point. Similarly, sine is measuring how far left. Again, on a scale of 1 means it points perfectly up, 1 means it points perfectly down, and then we just have some in-between values. So again, let's try drawing some examples. Here's our unit circle. Put in the x-axis and y-axis. Why is this not straightening out? There we go. This is a little asymmetrical, but that's okay. I want you to get the idea and not be caught up on perfectly drawn pictures. So as an exercise, right, get 1 or 2 partners and just take turns drawing your axes in your unit circle. Okay, let's try to make this a little bit better. I do want this to look symmetrical. Okay, that's pretty good. So just draw an angle in standard position. And just estimate, what do you think sine and cosine are? Here's theta. We're imagining this point, right? Compared to, so left and right, I'm pointing left. And how far left am I pointing? Well, it's not that far left. And if we actually measured, right, I'm going to do some examples with a grid later on, but you could think, where is that x coordinate? If I go straight down here, Here's x equals 0 here at the extreme of the unit circle. Here's x equals -1, and we're somewhat halfway in between. So if you said cosine of theta is approximately -1/2, that's a pretty good estimate. Anything in that ballpark. It's definitely negative, and it's kind of a medium negative. Not too close to 0, not too close to -1. Line is measuring how tall, how upward does this point? It definitely points upward, and it points almost completely upward. But if you actually measured the y-coordinate of this point compared to the y-coordinate at the very top of the unit circle, those heights are almost the same. So our y-coordinate here is almost at the very top of the unit circle. It's probably something like 0.9. If you said 0.8, something like that, that's fine. Right? Don't worry too much about the specific numbers, but you want to look at that direction and say, is it pointing left? Is it pointing right? How much? That lets you estimate cosine. And you want to look at this direction and say, is it pointing up? Is it pointing down? How much? That's your estimate of sine. So if you're watching this at home, just try some of these by yourself. In class, we will be, I will let people do it in groups and I'll come and help them out. And now finally, we can combine what we've been doing with information about special right triangles so we can find some exact values. Not for everything, right? If I say find the cosine of 22 degrees, that's not something you're going to be able to do unless you pull out a calculator. But for certain angles, we will be able to figure out what their cosine and sine are. And at a certain point, we might just memorize some really easy values. So let's do an example. Let's draw a -60 degrees in standard position. So here's my x-axis. Here's my y-axis. Here's my unit circle. Let's try to get this a little more symmetric. So -60 degrees would look something like so. We're going 60 degrees in the negative or clockwise orientation. So what I want to do is I want to actually figure out what are cosine and sine. And when I have a specific value, I would actually write cosine of -60 degrees. We're going to figure out what that is. And sine of -60 degrees. When you have a specific value, you don't really need to use theta. And let's just note that I am putting these parentheses here. If those parentheses were gone, then that looks, then that kind of looks like subtraction. It looks like cosine minus 60 degrees, which doesn't really make sense. Cosine is the name of an operation. Theoretically, whenever you write cosine, you should have cosine of something. There should be either the name of an angle or the measure of an angle next to it. Cosine of what? Cosine of -60 degrees. Or more generically, cosine of theta. It's like, it's the name of the computation. All right, now remember, by definition, our unit circle has a radius of 1. Every single point on this circle is exactly 1 unit away from the origin. We're trying to figure out where is this point right here. I know that this distance, let me change my color. This distance here is 1 unit. What I'm going to do is I'm going to draw a triangle to better understand where this point is. So I could go straight up like so. I'm going to erase this. Let's just remember that that was -60 degrees. I'm trying to figure out where is this point. I've created a triangle. Now, I know that this was a rotation of negative 60 degrees, which means this is a 60-degree angle. Not worrying about the orientation, that's a 60-degree angle. This is a 30-degree angle. And what we have here is a 30, 60, 90 triangle. We're going to start noticing a lot of examples where we can find a 30, 60, 90 triangle in our diagram. One of the rules, hopefully we remember about 30, 60, 90 triangles, is that the shorter leg is half the hypotenuse. So this distance here is 1/2. And then the longer leg is the shorter leg times the square root of 3. So this distance is 1/2 times the square root of 3. So just to be clear, these are pure distances. Now let's think about those as coordinates. What are the coordinates of this point? I've gone forward 1/2 of a unit. So the x-coordinate is 1/2. And I've gone down 1/2 times root 3. So the y-coordinate there is actually a negative number. This is something we'll be doing occasionally. We'll draw pure distances on our diagram, but then when we write coordinates, we'll think about, oh, did I go left or right to affect whether my x-coordinate is negative or positive? Did I go up or down to affect whether my y-coordinate is positive or negative? So by definition, the coordinates of that point on the unit circle corresponding to negative 60 degrees in standard position. Right, going back to our original, here is negative 60 degrees in standard position. We know where that point is, so we can say that cosine of negative 60 degrees is 1/2. As a decimal, that's 0.5. And sine is negative 1/2 root 3, which is approximately negative 0.87. And let's just check, does this make sense? Would we say that this terminal side has sort of a medium point to the right? Right, our cosine is positive, but it's almost one. When you're pointing almost perfectly downward, your sine value is almost negative 1. Let's try this one together. 135 degrees. So x-axis, y-axis, unit circle, try to make it symmetric. Okay, let's fix this a little bit. I promise you that the next section we do will have some perfectly drawn versions. So best, not bad. 135 degrees is 90 plus 45. So we'd look something like so. This is 90 degrees of rotation. This is another 45 degrees of rotation. So what we could do here is we could imagine this is a 45-degree angle. This is a 45-degree angle. And we could draw, there are actually two different triangles we could draw, but we want to find right triangles in this diagram. Either one of these triangles that I'm drawing in pink would be the key for figuring out where is that point. We are trying to figure out what is cosine of 135 degrees. What is sine of 135 degrees? The trick is to find the triangle. Also, by definition, the radius of the unit circle is 1. So this distance here is 1. Now let's remember, in a 45, 90 triangle, the hypotenuse is a leg times the square root of, times the square root of 2. So what we have either one of these triangles, be 1 over the square root of 2. Remember, we do like to rationalize. All of the legs of the triangles in this diagram have a length of root 2 over 2. This distance here is 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 root 2 over 2. In practice, you wouldn't need to draw both of these triangles, either one. Right? Whichever one occurs to you, great. So where is this point? So remember, I'm just labeling pure distances here. Here's the origin. To get to this point, we went left. So the x-coordinate is negative. But we went up, our y-coordinate is positive. So what we've learned here is that cosine of 135 degrees is negative root 2 over 2. That's approximately negative 0.7. Sine is the positive version of that number. Cosine measures how far to the right do we point. This terminal side points to the left. Cosine is negative. And if you think about it, this coordinate is, kind of 2/3-ish of all the way across. We're pointing somewhat substantially to the left. Not super duper close to the left, but somewhat substantially to the left. So our cosine is a big-ish negative number. Not super close to -1, but certainly not tiny. Sine is measuring how far upward does this point. How much does it agree with upwardness? It's definitely going up, so sine is a positive number, and it's going up somewhat substantially. Again, thinking about this y-coordinate, the y-coordinate here compared to the very top, it's kind of close. So we're getting a reasonably big y-coordinate. I'm just going to warn you that these specific numbers that we're seeing, root 2 over 2, 1/2, 1/2 times root 3, they will be coming up over and over again. So at some point, you're just going to notice some patterns, and you're not going to have to do all this work. So if you're doing this home alone, hit pause and try to do the same kinds of things for these 4 angles. 180 degrees, 30 degrees, negative 45 degrees, and 270 degrees. Right. Hit pause and do your best. And now I'm about to go through them. And I will be doing this somewhat quickly. Okay, so for 180 degrees, we'll draw our axes. We'll draw our unit circle. We'll draw our unit circle. This is not going so well. All right, good enough. 180 degrees, here's my initial side pointing to the right. 180 degrees of rotation, my terminal side would be pointing perfectly left. So 180 degrees of forward positive rotation looks like that. The point we have in mind. Now for this example, we're not going to draw a triangle. We're just going to notice that this is the leftmost point of the unit circle. top, bottom, left, right points of the unit circle, you should just know what those coordinates are because one of them is 0 and one of them we've gone 1 unit. So here, once you have the right picture, this one's actually very easy. Cosine of 180 degrees is that x coordinate, which is -1. We're pointing perfectly to the left, so our cosine is -1. In terms of how far up we're pointing neither up nor down, so sine is 0. That y coordinate is 0. X coordinate is -1, that's cosine. Y coordinate is 0, that's sine. And they make sense. Next example is 30 degrees. X-axis, y-axis, unit circle, not bad. Here is my initial side. Here is my terminal side. I want this to look like it is approximately 30 degrees. Pretty good. Let's draw a triangle. Here's the point we're trying to find. This distance definitely is 1. If it's the unit circle, that button. If you wanted to, you could have done it a different way. Go across like this. Anything that creates a right triangle will work, but you don't need to do both. I think it's usually easier to go down or up rather than left or right. So what do we remember? So this longer leg is short leg times √3. So this is 1/2 times √3. So do we know the coordinates of that point? Yeah. Both of them will be positive. Right, we've gone √3/2 units. Upward, we've gone 1/2 unit. So what we can say in this example is that cosine of 30 degrees is √3/2. That's approximately 0.87. We've seen that number before. Almost to the right. Not perfectly to the right, but it's very close. Almost perfectly to the right. The cosine value is very close. Medium, pointing up at all. Our next example is y-axis, unit circle, I am not good at making these circles today. Here we go. -45 degrees. So initial side, terminal side, 45 degrees is sort of in balance, but it's negative. So this is our angle like so. Let's draw a triangle. We're trying to figure out where's that point. Straight up like so. My triangle. With the unit circle, always keep getting that the hypotenuse is 1. Here's a leg, here's a leg. We have that relationship that the leg times the square root of 2 equals the hypotenuse. So in this case, the leg times the square root of 2 equals 1. The leg will be 1/√2, which simplifies to root. If you feel like we already did this computation and it's just kind of sort of the same answer, you're onto something. There are only so many patterns that we're expected to know, and at a certain point you might notice, oh, this is just like the one I did before, except maybe now x is negative instead of positive. or y is positive instead of negative, but it's the same kinds of patterns. So we could go back and say this distance here is, let me make this easier to read. This distance here is root 2 over 2. This distance here, can I erase just this? This distance here is also root 2 over 2. So where is that point? Well, based upon the diagram, we know the x-coordinate is positive and the y-coordinate is negative. Cosine measures how much does the terminal side point to the right. Points to the right somewhat substantially. How much does the terminal side point up? This point. Unit circle. We don't need to draw a triangle. Just know that the location of that point has an x-coordinate -1 because it's 1 unit away from definition is cosine. Cosine is measuring how much does this point to the right? Doesn't point to the right, so cosine is 0. Sine is measuring how much does this point up? Well, this point's perfectly down. That's the opposite of up, -1. So all of these are very doable. If you have an angle that's a multiple of 30 degrees or 45 degrees, something like what we've done here will work. And very soon you want to just start latching onto the patterns. The same kinds of numbers show up over and over again. So the faster you latch onto the pattern, the more you'll be able to get these answers without spending a ton of time drawing detailed diagrams. So that's what's coming up next. But that's the end for now.